Welcome to Maths and Science by IITian channel. In this lecture, I will be discussing about the most important, tricky, complex matrices concepts. These are very important to understand and to answer the questions in IIT JEE Mathematics. It's a little bit advanced topic, but however, it is required to understand the concepts clearly so that even any tough question we will be able to answer. Here I will be talking about, from the whatever I have given here, Aij is not equal to conjugate of Aji. What is its meaning? And there are different possibilities in complex matrices. Aij is equal to complex conjugate without transpose. Aij is not equal to conjugate transpose. Aij is equal to Aji. What all these things mean, we will study. These are all pertaining to properties of complex symmetric matrix and Hermitian matrix, which is also a complex matrix. These are all mainly regarding the complex matrices, Hermitian matrix and complex symmetric matrix. What is the difference between them and how we represent them and what are the qualities of them, we will be discussing in this lecture. Very important lecture, please listen to it carefully. First one, what is a complex matrix? Complex matrix is a matrix in which complex numbers are there as elements. Real numbers will also be there. In addition to that, complex numbers also will be there. Either of them will be there. Now, what is the meaning of the complex symmetric? A symmetric matrix regular symmetric matrix implies A is equal to A transpose. This is regular with real numbers. Under this we will define complex symmetric matrix implies A is equal to A transpose, where A is a complex matrix. I have told you a complex matrix is a matrix which has complex numbers as elements. Now, a complex matrix is there. What is a complex number? Complex number is in the form Z is equal to X plus Iy. It is a complex number. And a matrix having complex numbers as its elements, at least one of the elements is a complex number, then it is a complex matrix. If none of them is a complex number, their elements, then it is a real matrix. Now, we will be dealing in this class, in this lecture rather, we will be talking about the complex numbers and complex matrix. Symmetric complex matrix means A is equal to the matrix itself is equal to its transpose. Now, I have already discussed about complex symmetric matrices in the previous lectures. You please recollect from there what is the complex symmetric matrix. In the symmetric matrix, rows are equal to columns. A is equal to A transpose means rows are equal to columns. Here I will give the example also for clarity. You take this example. Let there be a matrix A one plus I 2 2 5 minus I. What is it? It's a complex matrix. Because complex numbers are there, it's a complex matrix. What is its transpose? Transpose is columns will become rows and rows will become columns. First column is 1 plus I into 2. This is first column. That become row here. And second column is this 2 5 minus I. That means A transpose is nothing but A. This implies symmetric, complex symmetric matrix. We can call like that. Complex symmetric matrix. Now, that means in complex symmetric matrix, how we can write the any element? It is A11, it is A12, it is A21, it is A22. In this, what is that similarity you are getting? A21 is equal to A12, A12 is equal to A21. Understand from the simple only, simple examples, and we can widen our scope in mathematics. That means Aij is equal to Aji. Do you agree this? In a complex symmetric matrix where complex numbers are there in the matrix, Aij is equal to Aji. Aij is equal to Aji is equal to, we are talking about only complex matrices. Complex symmetric matrix. Now, second case. Let us talk about the Hermitian matrix. It is a complex matrix. It will be very useful in advanced mathematics and advanced physics subjects. Please understand Hermitian matrices well. Hermitian matrix is, what is that Hermitian matrix? The transpose of the conjugate is equal to A. A is equal to conjugate transpose, which I have discussed in the previous lectures in detail. Let us take one example so that you will understand well. Example, A is equal to a complex matrix 2 1 plus I 1 minus I 4. What is its conjugate? Conjugate of a real number is always a real number. Conjugate of a complex number plus becomes minus. That's all. Simple trick. 2 will be 2 only. 1 plus I becomes 1 minus I. 1 minus I becomes 1 plus I. And 4. 4 becomes 4 only. Then what is the transpose of the conjugate? rows will become columns and columns will become rows. This is the first column and first column becomes row 2 1 plus I, second column becomes second row 1 minus I and 4. This is equal to A. This is the example of a Hermitian matrix. What is the property of Hermitian matrix? This is A11, A12, A21, A22. What is the property of the Hermitian matrix? A12 is equal to conjugate of A21. Implies, you see these two. A12 is equal to conjugate of A21. If there is a bar on the top, it's conjugate. It's not transpose. Don't get confused between transpose and conjugate. Conjugate complex number, how it will be? If Z is equal to X plus IY, then conjugate of Z is equal to X minus IY. Please remember this property. Conjugate is always the plus sign between, the sign between addition or subtraction becomes opposite. Plus becomes minus and minus becomes plus. That is a simple way of understanding the conjugate. Now, A12 is 1 plus I. A21 is 1 minus I. Conjugate of 1 minus I is because conjugate of 1 minus I conjugate is equal to 1 plus I. Or 1 plus I conjugate is equal to 1 minus I. Please understand this concept clearly. Hence, A12, 1 plus I is equal to conjugate of 1 plus I. 1 plus I is equal to conjugate of 1 minus I. This property. A12 is equal to conjugate of A21. And these are all explained in the previous lectures. Please listen to them. Please listen to them. Now, here, what is the property we can write? Property of a Hermitian matrix is Aij is equal to conjugate of Aj. Please remember this. This represents Hermitian matrix. And Aij is equal to Aj. Both are if complex. Both are if complex matrices. This represents, what is that? Aij is equal to Aj, complex symmetrics. Now, the question is, we have to verify the given question. To which it belongs? To which it belongs? This belongs to what? Aij is not equal to conjugate of Aj. Given question is, we have to understand the properties of Aij is not equal to Aj conjugate. If Aij is equal to conjugate AJI, then it is Hermitian. Hence, from the above definitions, it is not Hermitian. If there is a question given in JEE Advanced to find out the multiple answers, that this property is given, find out the relevant true statements. Question can be, a matrix is represented by a complex matrix, rather I can write here, represented as Aij is not equal to Aji. Then alternative can be Hermitian matrix, second alternative can be non-Hermitian matrix, C. In general, the eigenvalues are complex, the eigenvalues are real. We have to find out how many alternatives in this are correct and which alternative is correct. Here, first we have already decided that a complex matrix is represented as Aij is not equal to Aji. Then we have found out that it is not a Hermitian matrix. This is correct. Hermitian matrix, this answer is wrong. This already established. Next, we have to talk about the eigenvalues. The eigenvalues of a Hermitian matrix are always real. Here we can write. Please note this. The eigenvalues which I have already discussed in the eigenvalues lecture. Please refer to my eigenvalues lecture. The eigenvalues of a Hermitian matrix are always real. Please remember this and prove it as a homework. Hence, this is wrong. Now, the debate is between B and C. In general, the eigenvalues, because these are all always real, then it is a non-Hermitian matrix. In the non-Hermitian matrix, complex matrix, in the non-Hermitian complex matrix, in general, the eigenvalues can be complex. The eigenvalues can be complex because if Aij is not equal to Aji, it doesn't negative the what you call possibility of Aij is equal to Aji. That is complex symmetric. It is a complex symmetric matrix property. That means this is possible because we can't rule out. Aij is not equal to conjugate of Aji. Aij not equal to conjugate of Aj does not necessarily indicate that Aij is not equal to Aj. Here complex is not equal. It does not necessarily indicate that Aij is not equal to Aj. That means possibility of Aij is equal to Aj can be possible according to the given matrix. If it can be possible, then it can be a complex symmetric. Hence, the answers B and C are correct. Answers B and C are correct. It can be a non-Hermitian matrix, and it is a non-Hermitian matrix, and it can have complex numbers as eigenvalues. I think there is a value addition to your knowledge. If there is a value addition, I want to stop this lecture here. And for basics on different types of matrices, their applications, please refer to my earlier lectures. And this type of questions are possible in IIT JEE Advanced. This is a question developed by me, not copied from any book. And on the basis of the pure concepts, if there is a value addition because of this lecture to you in developing the concepts in linear algebra and in matrices, please share this video, share and subscribe to my channel Maths and Science by IITian. So that you will get regular updates on my new videos being released regularly for Maths Olympiad, JEE Mains Mathematics and JEE Advanced Mathematics. Best of luck to everybody. Thank you for listening to me. It's a very tricky question. This type of questions you may expect, if not on complex numbers, even on real numbers also we can expect this tricky type of questions. I will come up with another tricky question in linear algebra in the next lecture. Till that time, best of luck.